Hey, what's up, everybody? Today is March 18th. This is going to be my second problem of the day. We're going to go ahead and just practice our type racer and then move on to Leetcode. A little better. Okay. 9191. Minimum operations to make binary array elements equal to 1. Okay. You're given a binary array nums. You can do the following operation on the array any number of times, possibly 0. Choose any 3 consecutive elements from an array and flip all of them. Flipping an element means changing its value from 0 to 1 and from 1 to 0. Return the minimum number of operations required to make all elements in nums equal to 1. If it is impossible, return -1. Now, I have done this problem before, and I actually remember doing it, so I'm just going to show you the way that I remember doing it. So we're going to go ahead and go through and do it. So for this problem, I'm going to take a greedy approach. Oops. We're going to have an integer to store result. We're going to go through nums. And we only want to go up till the last, so that we can grab the last 3 values. And then if the first value, so here's the thing. We know that if the first value is 0, then no matter what, we have to swap that one and the next 2 values. Okay. And then we know that we just have to iterate through until we find the next 0. So we would say on this first example, we would have 0, 1, 1, 1, 0, 0. If we flipped the first 3, right? So it would be, whoops. Okay. If we first flipped the first 3, we would have 1, 0, 0, right? And then 1, 0, 0. So then we would go to the next value, and we'd have to flip the next 0, right? Thus, because we're iterating through by ones. So then we would flip 0, 0, 1, which would make it 1, 1, 0. So we would have 1, 1, 0, 0, 0, 0. Oops. 1. All right. And then we would go again and would notice that the last 3 are all zeros. So if we just flip them, we'd have all ones. Yeah. And I'm pretty sure this is a valid solution. So if we just implement it the way I'm going to do it, we're going to say if nums I is, or if not nums I, then we just want to flip the 3 values from I to I plus 2. And in order to flip a value, we're just going to go nums I XOR equals 1. And then we're going to do the same thing for the other 2 values. Like this. And for every time that we find a 0 that we're not going to need, or that we need to flip, then we're just going to say, we're just going to increase result, right? It just means that we flipped it. And by doing this iterative approach, we know that no matter what, it is either going to flip all of them, or the last couple are going to be zeros at the end. And I don't think there's any other faster way to do this, as far as I'm aware. So then we can say, so the ending result is we really need to just check the last three values. If any of those values are 0, then we basically want to return that it's false, that it's not, that doesn't work. So we'd return a -1. Okay, so basically what I'm going to do is I'm going to say I want to return, and then if any value is 1, so if I said nums dot size -1, which is the last value, okay, so if any one of these, wait, no, I set this up wrong. If any of these are 1, that's not what we want to do. What I want to do is I want to say if they're all 1. That's better. So if this is 1, this is 1, and this is 1, we know this is a true value, right? And if it's true, we can return result. Else we return -1. Yeah. Okay, we're going to go ahead and submit that as is. Yeah, and it's good to go. Just to be sure, let's go ahead and see what other people, or what the editorial says. They used a deck. It's O of n. I mean, we're using O of n. They're using a sliding window. I mean, in a way, we're just checking 3 values every time, so technically it's a sliding window, but we don't need to move the left-hand side. Accumulate. Well, I guess you could just add up all the values. But that shouldn't matter, because if... See, here's the thing. And this is why the greedy will always work in the situation that we're doing it. If we have... And I don't know why they're doing it this way on the editorial. If you say you had... I don't know. Let's say we had 3 zeros, right? If we're checking the last 3 values, or the first, from the first, right? We know the 0. We end up flipping all 3, right? And then we're checking the last 3 values. If they're all 1s, it's true. So what happens if we have 4 zeros, right? We would flip the first 3. Okay, so you'd have 3 1s and a 0. Then you'd go to all the way to the end, and notice at the end you have a 0, which would make this false, which means that it wouldn't be possible in any way to flip this to make it 0. and it expands up because I don't know. Let's think of longer solutions. Let's say if you have, I don't know, some random thing, right? Right. So you're here, right? And we just iterate through. We say, okay, our first 0. So we're checking the first value. We flip the first 3. Okay. And then we're left with the rest. And then we find the next 0, which is here. And this is sort of a greedy approach. So we're going to go ahead and flip the next 3. I did that wrong. Hold on. But this and this is flipped. And then the rest is the same. Okay, and then find the next 0 right here. Flip the next 0. Okay, flip the next 0. Keep on going. The next 0 is this one. Boom. And from this point, we know because we've reached the last 3 values, we have a 0 in the last 3. We know this is false. Yeah, it's greedy. I can't think of a better solution than just go iterating through each individual thing. Okay. That's my solution for today's daily. I hope it made sense, and I hope you have a wonderful evening. Peace.